In a previous tutorial I had a look at finding the determinant of the 3x3 matrix. We're now going to extend this to finding the inverse of a 3x3 matrix. So this is a very in-depth process, so my suggestion is that you take it slowly, pause the video, look back at all the calculations, make sure you understand what we're doing at each step. So the question asks, the matrix M is 1, 4, minus 3, 2, 6, 1, 5, 7, 6. Find the inverse M to the minus 1 of this matrix, where that power minus 1 denotes the inverse of M. Step 1. Find the matrix of minor determinants of M. So in a matrix, every element has its own what's called a minor determinant. So let's take this element here, 1. The minor determinant of 1 is obtained by crossing out its row and column and then finding the determinant of the matrix that remains. So the matrix that remains here is 6, 1, 7, 6. Find the determinant of that, 6 times 6 minus 1 times 7. So 36 take 7, which is 29. The next minor determinant we're going to work out, we're going to go down one element. So that element 4 there, cross out its row and column. 2 times 6, take 1 times 5. So 12 take 5, which is 7. Systematically working down this column again. The minor determinant of minus 3, cross out its row and column, and we end up with 2 times 7, take 6 times 5, so 14 take 30, which is minus 16. And notice this is similar to the process that we followed when finding the determinant of a 3x3 matrix. However, when we were finding the determinant, we times by the element that we crossed out the row and column of. We're not doing that here. We're only finding the determinant of the matrix that remains, not timesing it by the item whose row and column we crossed out. So we've done the first column here. Let's move on to the second column. So cross out 2's row and column. So the matrix of the minor determinant for this is 4 times 6, take minus 3 times 7, so 24, add 21, which is 45. Now the middle item, cross out its row and column, 1 times 6, take minus 3 times 5, equals 6 plus 15, which is 21. Moving down 1, cross out its row and column, 1 times 7, take 4 times 5, so 7 take 20, which is minus 13. Then moving on to the final column, so the minor determinant of 5, that element 5 on the top right, in this case is 4 times 1 minus 3 times 6, so 4 add 18, which is 22. This one here, cross out its row and column, we've got 1 times 1 minus 3 times 2, so 1 plus 6, which is 7. Then the final minor determinant we're going to work out is that of the bottom right element. 1 times 6, take 4 times 2, which is minus 2. So in order, we're going to put these into a matrix. So the matrix of minor determinants, well, the top left one is going to go in the top left, middle left, go in the middle left, and the bottom left is going to go in the bottom left here, and so on. So 29, 7 minus 16, 45, 21 minus 13, then 22, 7 minus 2, and that's the matrix of minor determinants. Okay, so that's the first step done. Step 2, change the sign of every alternate element of the matrix of minor determinants to obtain what's called the matrix of cofactors. So the sign changes that we're going to apply to every alternate item, we're going to apply the following sign changes. So every other element, every alternate element, we're going to change the sign of. So no sign change to the top left, then a sign change to the left middle, no sign change to the bottom left, change, no change, change, no change, change, change. So applying this sign change to this matrix here, we end up with the matrix of cofactors, which we're going to call C, equals 29, not changing the sign of that, but this one we are going to change the sign of, minus 7, then no change to that one. Then we are going to change this one, minus 45, we'll negate it, 21, then a change of sign to this bottom one to make it positive 13. Then the top right, no change to the 22, we are going to change the 7, and no change to the bottom right, minus 2. So this is called the matrix of cofactors. We've taken the matrix of minors, applied this sign change to turn it into what's called the matrix of cofactors. Step 3. The inverse is equal to 1 over the determinant of M times this matrix of cofactors after it's been transposed. So we've already worked out the determinant of this matrix in a previous tutorial. If you want to see how to do that longhand, please do go and have a look at our other tutorial video. But what we're going to do now, we're going to shortcut this and we're going to find the determinant using the calculator function. So, menu, and go to matrix mode, which is mode 4 there, and we're going to define a matrix A, a 3 by 3 matrix, and the matrix M we're going to put in there. So 1, 2, 5. I prefer to say matrices in columns, but unfortunately the calculator inputs in rows. So 4, then 6, then 7, then minus 3, 1, then 6. Operation and matrix calculation we're going to do. Operation, then scroll down, we can see there's the determinant, operation, matrix A. And we can see that the determinant is 49. Again, if you want to see how to do that longhand, if you want to see the method that the calculator uses, have a look at our other tutorial video. So equals 1 over 49. Then the transpose of our cofactor matrix. So what I'm going to do, I'm going to swap all the rows and columns. So I'm going to read it in columns, but I'm going to write it in rows. So 29 minus 7 minus 16. I read it down in columns, but I wrote it down in rows. Then minus 45, 21, 13. Again, I'm reading the columns, but I'm writing it down in rows. 22 minus 7 minus 2. And that there should be the inverse matrix. Now, if this question was asked in an exam, like it has been here, it probably would only be worth 1 mark, because we can just use the calculator to find the inverse of a matrix. I'm going to show you how now. So, going back into matrix mode, let's define our matrix A, which is going to be a 3 by 3. I'm going to type that matrix in. As you know, I prefer to write to say matrices in columns, but the calculator unfortunately inputs it in rows. So 1, 2, 5, 4, 6, 7, -3, 1, 6. Operation, matrix calculation. Operation, I want to take matrix A, and the button that finds the inverse is this x to the -1 button here, that finds the inverse of matrix A. So the first one, top left item, as we can see here, it's highlighted 29/49. So yes, that's correct, 29/49. Scroll down, -45/49, yeah. Scroll down again, 22/49, that's correct. -1/7, so that's -7/49, yeah, that's -1/7. -3/7, well, 21/49 indeed is 3/7, and -1/7 again, yeah, -7/49 is certainly -1/7. -16/49, -13/49, and -2/49. Yeah, we found the inverse of the matrix M. For more tutorial videos like this, subscribe to our YouTube channel or go to alevelmathsrevision.com.